So this one is, this question is a bit more difficult because it will involve a cosine rule. So just now, my previous question, we were doing minor segment. So right now we are actually having something called a major segment. So that means that originally it will look like this. So originally it looked like this. And this part here is the minor segment. So the minor segment is like the previous example, the icing example. Okay, so the major segment is this whole thing. So the major segment is one of the more difficult one. So that is like a tunnel. Like if you walk through a tunnel, or it can be a train tunnel. So the red color one is the major segment. So I think in the first teaching worksheet, when I introduced to you this topic, I mentioned something about major segment and minor segment. Okay, so we got the radius and we got the horizontal base. Okay, so the first thing, right, we are supposed to be showing reflex POQ. So some of you may be wondering, where is this reflex? This reflex is here. Reflex is more than 180 degrees. So in actual fact, if you were like that, right, you got to find POQ, the obtuse part. You got to find the obtuse part. So I'm going to show you two ways of doing it. So I'm going to enlarge this triangle to show you. It's your choice which one you want to go about doing it. So O, P, Q. So I'm interested to find this angle. So maybe I call it X. Okay, and this is a 7.6. This is a 7.6. This is a 14.5. So one way of getting X, right, will be doing a cosine rule. So you can try out the cosine rule. But when you try the cosine rule, please make sure your calculator is in radian mode. You go and give it a try to see whether you can find it as 3.75 radian. So another way, if you don't like to be doing cosine rule, there is another option. Okay, maybe I draw a nicer one. There is another option. Okay, whichever option you take, it will still give you the 3.75. You can give it a try later on. So this is an isosceles triangle. The good thing about being an isosceles triangle is when it cuts 90 degrees, this part will be 14.4 14.5 divided by 2. Because there's an isosceles triangle, it will cut perpendicular into 2 halves. So some of you may prefer to find through normal trigo. So this one will be opposite, this one will be hypotenuse. So some of you might prefer to find like this. And you do your sine inverse. So some of you may prefer to find like this. If you're finding like this, is fine. But you need to remember to do it in radian mode. That means you do it in radian mode. You do the sine inverse in radian mode. So POQ will end up to be 2 times of this. Oh, I forgot. When you find this, you will not find 3.75, not yet. Oh, you're not finding the 3.75. Okay, sorry. So you will find this in radian, but the question is asking you for reflex. So reflex, basically you are taking 360 to minus this part. But of course, right now you cannot take the 360. You got to get 2 pi. So you will get 3.75 radian. So in this case, if you do the cosine rule, your x will be the 2.53226 radian. So if you would like the reflex, you got to go through the same thing. But instead of using 360, you got to be using 2 pi. So it shouldn't change your answer. You will still get the same 3.75 as a reflex answer. So whichever you prefer, you just go ahead. Okay, so my POQ should be 2.53226 radian. So if I do the reflex one, that means this part, I should get 3.75. So it depends on how you want to do it. Do you want to do it by the cosine rule, or do you want to do it by the normal trigo, the right angle trigo? Okay, I'm going to erase off so that I have the space to explain part 2. So please make sure you note down the method you like first. So for part 2, we're going to find the triangle POQ. So the question says, I'm supposed to first find the area of triangle POQ. So I'm going to find the area of triangle POQ, which is half AB sine C. So you should half AB sine C with not the reflex angle. So I should be using this one, not the reflex angle. Then go and punch calculator. And remember, it must be in radian mode. So you will get 16.528569 centimeters square. Okay, in this case, it's meter square. I need to find the whole tunnel. So meaning I need to find the, okay, maybe I change color. I need to find the major sector. This is the major sector, a pizza. This is the big piece of pizza. So I need to find the major sector. So if I'm going to find the major sector, I got to use the 3.75 that I gotten just now. So that should be half r square theta. The theta is the 3.75 that I found just now. So from here, I'm going to find my tunnel, the cross section of the tunnel, the total area of the cross section. So that will be the triangle plus the major pizza. So 3SF will be 125. Okay, so the answer is correct. So if you take a look, right, the major segment is like a major sector plus a triangle. So major, it is a triangle plus a major sector. In part 3, they want the alternative method. And this alternative method must involve the whole circle, the area of a circle. That means I will still get the same answer, 125. So again, I'm going to erase this. So I'm going on to part 3. I'm going to find the same thing. But right now, I must involve the whole circle. So you might be thinking, where is the whole circle? So this is the whole circle. So I'm going to find the whole circle first. And I'm going to leave it in terms of pi. So that is my whole circle. So how can I be finding this, the same tunnel? How can I be finding the same tunnel? So I'm actually going to find the blue segment here. So I'm going to find the minor segment. How do we find the minor segment? So it's like the previous question. I'm going to find the minor segment by using the minor pizza to subtract away the triangle. So minor sector will be half r squared theta. Triangle will be half AB sine C. So which angle should I be using? I'm using this one. So this is the blue pizza. So I should be using this one. This one. So I will be using half r squared theta. And I will be using half AB sine C. So I should sine the same angle. So it looks like a chain, but it's still not so bad. So remember, your calculator needs to be in radian mode. So you will get 61.75425. So that is the blue segment. So now I'm going to find my tunnel. So this is my tunnel. So this whole thing is my tunnel. So to get the tunnel, same idea. You just use your circle and subtract away the minor segment. So in this part, right, it seems like it differs a bit from the answer. So it's a bit like different. Let me see whether, so now I'm getting 120 compared to the 125. Sometimes different method might give a bit of discrepancy. So let me check. Did I make any careless mistake? So let me check my minor segment, the blue part. So I try pressing calculator one more time. And I double check that I'm in radian mode. Yeah, I think I pressed wrongly. So this part, I think it should be 56. So I should minus away 56. So if I use a different method, it doesn't make sense that my answer is like too much difference. So sometimes can be a bit of discrepancy, but it shouldn't be too much. So now let me try. Yeah. So I get 124.855. So sometimes the decimal can differ a little bit. So let's round off. I'm still getting the same area. So would you prefer a circle minus the minor segment, or a triangle plus the major sector? So during O-level, right, if you're asked to find major segment, these are the two methods. So hopefully you are clear about the two methods.